I'm Stephen Foskett from TechFieldDay.com. One of the great things about Tech Field Day is that we get to bring in so many fantastic experts in various fields. And in networking, the Packet Pushers podcast is the place to listen to these networking experts. And happily, we have, two familiar faces from Packet Pushers right here around the table with us all week at Networking Field Day 11. So we've decided to do a special crossover edition of Tech Field Day / Packet Pushers podcast. So that's what you're watching here. It's a little bit different from what you've experienced up to now, but we'll be posting it in our feed on YouTube and our website, and they'll be posting it as well on their Packet Pushers site and the Packet Pushers podcast feed. So.
Welcome to the Packet Pushers Weekly Show, and this week we're coming to you from Silicon Valley, grouped around a table for a Tech Field Day roundtable discussion. And if you don't know what Tech Field Day is all about, you can get a look at techfieldday.com and read up, but the short version is that periodically a group of independent, community-minded technical folks gather together to hear a series of presentations by IT vendors. And we've wrapped up just such an event called Networking Field Day 11, and we thought we'd have a chat with the delegates to get their take on the big ideas we heard and how they impact our actual production networks. So I'm Ethan Banks, and full of piss and vinegar is Mr. Greg Farrow.
Oh, what? Harsh. Fair, but harsh.
The piss and vinegar was not happening earlier in the week because you were sick and miserable and all the rest.
Yeah, I got infected on the plane on the way over. It was sort of the biological malware that lays you low, but I've sort of been bouncing back as the week's gone on. Lots of energy here in the room, as you can see if you're watching live for this event, because it's actually on camera. We'll have a version of this on YouTube. So if you want to see ugly faces and why we record a podcast and don't actually do video, by all means tune into that. But let's go on with the show. We've got a lot to talk about and not a lot of time.
What we're going to discuss today is how the things that we have heard presented at Networking Field Day 11 and how they impact our production networks. I've broken the discussion up into three parts here. Security architectures, core architectures, and WAN architectures. So these are going to be some open-ended questions, kind of inspired by the vendors that we heard present at NFD 11. So let's start with security architectures. We heard some security-related presentations this week. One question that came to my mind as we were listening to Skyport, do you think that banking on security hardware makes sense in a world where workloads are both virtual and mobile? In other words, the workloads move around. What did you guys think of a lot of intensity and focus on the hardware?
I've always had a pain around the DMZ, right? If you've ever built a corporate DMZ, and I know you have, Dominic, right? Yeah. 4 layers of firewalls and proxy servers and load balancers.
Only 4?
Yeah. But it's not, running all those firewalls is hard, but getting the networking between them is hard. And what we saw Skyport do is say, let's just build a system that does that securely. So it's sort of SDN, if you think about it in that sense, but it's actually a trusted computing platform. Crypto processors, trusted process modules, all on a special card inside a hardware platform, so you can run VMs securely and safely. It's got a lot of applications.
Yeah, but what if I don't want to be married to some physical piece of hardware? I mean, because isn't that the whole point of cloud and so on? I can move my workloads around everywhere, and
sure,
I don't want to be tied to a box.
You can go and get a KVM or a VMware and run up some ESX or whatever, but you don't actually get the networking stuff that steers you between it. What you actually still have to build after you put hypervisors on an x86 server is the connectivity between the servers, then the isolation or the microsegmentation, and then you've got to build a monitoring platform that monitors the traffic between them. And what Skyport showed us is that with the right approach, you can secure it in the hardware beyond any sort of audit or any sort of practical consideration of doubt, and deliver all the analytics and the monitoring that you need to make that work.
We talk all the time. What do you guys think?
So in healthcare and retail, I mean, security is important, right? Mobility, not so much important. A lot of those solutions are going to be in campus, going to be in 4 walls. Agentless is huge in healthcare, right? You can't go putting agents onto servers, onto VMs, right? You've got FDA, all these regs where you can't touch the hardware, right, because it's been certified or blessed. So in retail, I think it's big for cardholder information, right? Especially, again, you don't want to go put agents on, protect PCI, protect cardholder, and then in healthcare for HIPAA regs, again, protecting PCI or PI, right, patient information.
So, Michael, your point being then it is use case specific, and you're seeing a use case for a security hardened platform like Skyport.
Definitely.
I'll say too, here's what I think I heard from them. You talked about having it tied to hardware, but I also heard them say, Skyport say, that we could actually have it not tied to just their hardware, right? We could still have something off box sitting in there behind one of their containers. And their container is essentially a DMZ, right? So at that point, if we're doing something that's not on their hardware, you'll lose those features of being able to see if somebody messed with the kernel or messed with the image itself, but you still have that control between their do they call them containers? It's not containers. It's compartments,
They didn't want
right?
to call them containers.
Yeah, I know. I want to call them containers every time I say it. But so I don't know that it was completely tied to hardware, but the benefit was tying it to their secure compute hardware that they had.
Well, I think the other benefit too of it, right, is like, I think we're going to have security hardware either way we do this, and to consolidate that down into the host rather than proliferate all of these appliances on the network and make the network more complex for us to work on, I think that's a win and it's a step in the right direction.
Yeah.
This is definitely, though, an example of defense in depth, though, because it is at the host level, and they alluded to problems on the network many times. So we're using microsegmentation for those lateral attack vectors, and not necessarily still discussing the misconfigured firewall and the misconfigured code. So definitely a component, I think.
And they are addressing security from a completely new vector. They have found a spot that was not very well covered by any other product. So this is kind of unique of this solution for me. Yeah, maybe this will not be the only security appliance or solution that you have in your DMZ, but it can be a very valuable part of it. Yeah.
They were presenting this product more as as a use case for a very secure system. Maybe enterprises need to make the decision. Maybe we don't get both mobility and that flexibility as well as true hardened hardware-based security. So it may be, at least in the environment as it is right now, that we may not get both those options.
Which goes back to the use case point.
Exactly.
It's going to fit into certain places.
My idea when I saw what they were offering is that when you had an application that was incredibly critical and absolutely needed to be secure, this hardware would ensure that, right? The mobility component may be something you have to discuss afterwards. Can we do it mobile on top of the secure? But this is when security is number one. This is the type of platform you need.
Yeah, that was my perspective. Is this is for a certain class of applications where BIOS attacks and stuff like that are in the hardware are really critical, and so they're basically validating that the hardware platform on which you're running this is secure, and then from there your application can then be guaranteed to be secure. And mobility was not one of the sweet spots for them, and they admitted that, and I think that was good.
Okay, so now I'll play devil's advocate then and ask the question a different way. If you think about your security architectures and the apps that we run in our environments, do we really have to detect breaches immediately? Or do you think if you pick up the problem after a few days, that's acceptable to the business? And that question is rooted in, there are other solutions out there that kind of presume you're going to get breached, and they'll detect it at some point, and then you act on it and mitigate in whatever way, and that's okay. Is that okay? Or must it be, you have to prevent, and if you do get breached in some way, you have to detect it immediately so you can act?
I think it depends on the application. Mike had mentioned yesterday or day before about some of the penalties for private information in healthcare, and those are pretty significant penalties. So if you have an application like that where there is high risk, then I don't think you have a whole lot of choice.
And somebody, maybe you have something that is sitting on the hard disk drive, on the firmware of your hard disk drive. You cannot detect it. You install the complete system new, and you still have that rootkit on your platform. Yeah, this solution will cover that for you. Yeah.
And how many people already have that problem, don't know it, and are still doing business just fine and don't care?
Just think of the operational cost of security. If you're building multiple firewalls together and you're connecting them together, you're probably configuring PV LANs. You might be using VRF Lite. You could be, and if you're building multi-data center DMZs to route traffic and HA the firewalls down and all that sort of stuff, building them into VMs makes perfect sense. But you've got a cost of operation of security. The way I see the new generation of security technologies, of which Skyport is one, and there are other companies that we've spoken to on the podcast, right? And they're all about lowering the operational cost. It's not what you pay to buy a firewall, although that's high. We've got to reduce that. But we also have to reduce I've got a team of 10 people whose job it is to configure firewall rules. We've got to find new ways to do those things. And that's the thing that I think is, that security is just too expensive because operationally it's too complex. So we need to have simpler And this is where SDN is going to be a big thing, is it's about reducing that cost in that sense.
So this is a really good segue to another question I'd written down here, which is, in your real-world environments, how often does security get sacrificed on the altar of convenience? It's too hard to secure the environment. That would make it too tough on the user, too difficult for us to use. Therefore, screw that, we're not going to do whatever it is. Something as simple as two-factor authentication or running a web application firewall that's sanitizing input. In the real world, what do you guys see? What's getting sent down to you from the C-level?
I think what's an interesting part of this conversation that it may add a little bit nuance to that question is, when is security being applied in the process? I think a lot of times we're fighting an uphill battle because security is an afterthought. We develop the product, we put it in place, and then we try to secure it. And because of that, security becomes much harder. And because of that, it becomes less palatable to spend the money to do it, and it becomes less effective because we're trying to do it at the edge rather than having it baked in. And so I think that that is one of the primary drivers of the fact that security doesn't get implemented as well as it should be, is because it's an afterthought. It comes in as a secondary component rather than being part of the process and part of the design from the very beginning.
I do think that that's starting to change. Just in my experiences working with various customers in a couple of different enterprises, and non-technical people seeing the value of implementing some kind of a security strategy from day one in a greenfield implementation. But I do think that it's the complexity that's the downfall, because everybody's eyes start to water and glaze over, and it also feels like it's a reactive thing. So we have these plans, we want to implement this thing and these rules to fire off, and then we're gonna, we found a GET request in this, and I have some regex that's gonna kill that TCP stream. But it's always reactive. As soon as I find out that it's interfering with my end users, we just turn it off. So it's a great idea, we have it, and then we turn it off. And then it's just a box sitting there, powered on a lot of the time, so we can still check our compliance box, but it's not doing anything.
You make a great point. When it interferes with the users, we turn it off. Every environment I've ever worked in, the security on the user side is, it's got to be simple, it's got to be easy. If it interferes, we'll turn it off or we'll turn it down. We'll leave it on, but have that checkbox. But then on the management side, it's a nightmare. Every single control you can ever implement to make it harder to just manage the stuff. So, when that's not where the attack vectors are usually coming from.
Then I'll bring it back to Skyport. Did what we saw in the demo, did that say to you, easy? I can leverage this platform in an easy way, or did it look like that's bloody complex, or it would be too hard to integrate in the way we do operations, et cetera?
Easier?
I thought it was much easier. And one of the interesting things for me was their concept of put the security right in front of the host instead of having it further out.
Well, I think we saw conceptually what it could do. I'm not sure we saw how easy it actually was to administer and configure in the first place and make it do what we want, right? So when you start adding the additional functions like taking private keys for SSL certificates and putting them in the middle, or doing username spoofing between front end and back end, there's a whole bunch of stuff. Now that was on one of them. Now you're going to rip out your UCS and HP and start putting in a bunch of these instead, because we want to secure everything we have. I have no idea how that scales management-wise. And I think that's almost their problem, right? Is up front it is going to be, as I see it, you put it in for the high vulnerability systems only, because everything else you're going to want to run on what you've already invested in.
For the corporate gems, right? Yeah, for the really important systems. Right?
It'll be very interesting to see if they're able to get into that position where the technology they've got, even if not in the current form factor, starts being able to be pushed into the kind of thing that people want to roll out rack after rack after rack, like the UCSs and the HPs and all the other blade chassis.
I think the thing we saw as a consistent trend this week through all the presentations was visibility. The ability to see management platforms, consoles, graphical things that showed me utilization paths. So part of what we saw with the security is not only did the demo showed us that we could see the configuration of devices much more simply than we could otherwise, but we've also seen companies like the Fluke people demonstrate their visibility tools. The SD-WAN, all the SD-WAN ones, NetScout. All the SD-WAN vendors from Silver Peak and from Citrix on their SD-WAN is about, the thing is that visibility of the WAN is built into those products. And just that visibility increases my overall security, because all of a sudden I've got this much more information. My mental cognizance of what the network is and where the traffic is and what it's going. I don't have to work really hard and interpret it from a ping packet.
Visibility in the context of security, though, I absolutely think that that's been the recurring theme the past couple of days. But I almost feel like it's the IP camera system sitting on my campus too. I'm not really doing anything but looking at who the bad guy was, so I can go and prosecute him after the fact. So firing off those rules with a fancy IPS rule set, that sounds attractive to me. But then, like we were talking about, we want to turn it off. So visibility is great, but I really do feel like, in the context of infrastructure security, application security, it's just like my camera system. I'm just looking at what's going on.
We should have had it for 30 years, but we haven't.
Stepping back to the ease part of the question, I think one of the other things about Skyport specifically is that they were doing a lot based off of the baseline, right? And so for any application or operating system or anything that has a level of dynamic change to it, I think that might be adding a layer of complexity that we're not dealing with now, where when we secure at the edge, we have a set of rules. This is the traffic allowed to and from the device. And that's what happens. Maybe local firewall will set. Now all of a sudden we do patches, we do updates, we do something, right, that's going to set us as a differentiation from whatever the baseline is. That now has to be treated in your security system as well to be identified as, yes, that was what we wanted versus that's not what we wanted. I mean, it's a whole new thing that we have to manage. So I think from that perspective, it's probably, it's going to add another layer of touch. But the other side of that is all of that information that we're now collecting through all these external tools is happening right on the box and being exported to a portal where we can look at it. So, that's probably going to be a bit easier.
So to wrap that up, I think Skyport particularly has a use case, has several different scenarios that it's going to fit, and it seems reasonable that we can actually use and administrate this product without it being too disruptive. So that makes sense. Okay, so from security architecture, let's move to core architectures. And by core architectures, that's almost a misleading thing to say, because what's a core look like today depends on what your data center's designed like. Now, one of the let's start with this. One of the things we got into was switching architectures. We talked about this with Dell and OS 10, what the Linux kernel looks like sitting on as the foundation of their switch platform. How comfortable would you be running, whether it's a Dell switch or one of several other brands that have taken this approach with their operating systems? How comfortable are you running that in your core, as opposed to what you're used to? It's a Juniper box running Junos, and by golly, we trust that. It's Cisco running NXOS, and boy, we trust that. We know what that's all about.
Juniper running
or do we trust that?
So I would ask back, what do you feel the difference is between that new model and what you're currently running?
Well, tell me what you think the difference is, because that's totally a loaded question, and I've actually written about this.
Yeah, and there are subtle differences, of course, but the reality is these technologies have been in use for a long time. It just so happens that we are starting to now get additional access to it because there are folks out there that have been asking for that. So it's really not a matter of are you comfortable having it in your production environment. I think it's just the question that you need to be asking is, do I have the right tools to make this work for me operationally?
Okay, my role as devil's advocate again. Dell announced specifically that sitting underneath OS 10 is an unmodified Linux kernel, Debian Jessie distro, as opposed to it's a Linux kernel that we're using and we've modified it heavily and it's not really a standard thing, and so it's special and it's different and that's our own unique snowflake that's secure and you can trust it and everything.
Right.
Do you think that anything's changed here now that it's a truly unmodified, here you go, kernel?
I think as a result we can enjoy a much wider test audience because this software is now no longer being used for our little niche. It's now being used for all kinds of things.
And you would position that software in the core of your network?
Sure.
Assuming a traditional...
Well, I mean, we haven't talked really about how the software on top is able to forward network traffic at performance. That's I think a different argument. But from a stability perspective, I would say that because we're actually using something that's not a special snowflake, we're using something that's been used for this kind of thing all over the place. It's just the typical case of this software has been looked at by more bodies, right? Mm-hmm. And I think that's a good thing.
You're making the case for open source software,
yes,
and actually seeing it as a positive to vendor proprietary.
Here's one. If I'm a CIO and I'm looking at my fleet of servers and I've got 10,000 VMs running Linux, so I've got all these people who can configure and instrumentation and technology running Linux, and all of a sudden over here there's a bunch of switches from vendor A using a completely different command line that doesn't use the same tools as my servers. And I might have 50 switches and 1,000 physical servers and 10,000 Linux VMs. I actually want Linux on my switch so I can use exactly the same command line. That's the CIO's point of view. Now, of course, as a networking person, configuring a CLI is much, much simpler than configuring 48 interfaces in Linux, because that's actually quite hard. But that's the purpose.
That's actually a question that I have about these Linux-based switches, and that is, are you configuring 48 interfaces in Linux, or is packet flow separate from the kernel? So basically, are packets actually flowing through the Linux kernel?
No.
Yeah, so this is, in a way, it's kind of a controller.
Only it's just the operating system that the switch runs on.
Right.
And there's a kernel module, and the configuration, so the app on top of the Linux configures the forwarding tables, pushes them through a kernel module into the ASIC. Everything's done in an ASIC. In the same way that you
Reminds me of Arista.
It's all the same for all of them.
Yeah, Cumulus does the same thing. It listens for netlink messages that would normally make it into the kernel, and they do, but they also send a copy of that translated into Broadcom terminology.
That's the way it's always been. All operating systems in network routers and devices have always been somebody's operating system, whether it's BlackBerry, RIM's, QNX, or whether it's been something custom developed internally by the vendor. So Juniper, for example, famously uses NetBSD. It's a Unix derivative.
FreeBSD.
Right? FreeBSD derivative that they, extend. This isn't new. The only difference now is that we're using unmodified Linux distributions as the operating system. And in there is an app that programs the switching silicon. That's it.
My opinion is here, I don't care what they do under the knees. If they use a standard Linux or in Juniper's case BSD or whatever it is. But if it is so that this enables faster development, faster new software that I can have on my systems that give me new capabilities, then it is a good thing. But what runs really underneath is not that important for me. I don't see that a proprietary system is more stable or an open system. Both can be tested and can be run stable, but I need maybe new features or something, and this has to be developed fast. Yeah.
I think the other piece of this that we're not talking about though is like these networking companies have gotten decent over the years at supporting a product line, right? Like the iOS has not drastically changed for a period of time, and now we're talking about something that's a little bit different. And I think inherently there's going to be lag in those support organizations getting up to speed on how to effectively support this new kind of operating system. Right. So from an enterprise perspective, you need to take that into effect, right? Like, how is this going to impact my mean time to resolution on instance I have on that platform as well?
Is the ability to take a switch like this, now part of the value prop, just back up a second here, part of the value prop of an open or disaggregated switch is you can run whatever software you want on top of it. Dell even took that to a different, more granular place and said you can run a third-party daemon on top of our foundation that's OS 10 and that Linux kernel and so on. So you could run layer 2, layer 3, Bird and Quagga, I think, came up in the discussion as a daemon that you could run on that, totally open source. Is that flexibility important to you in your network environment, or is it, going back to your point, Matt, the operational advantage you get being able to manage it with standard tools, or just the fact that it's been opened up to a lot more eyes to see what's going on under the hood?
So would I like to get access to all of those things and nerd out and be able to deploy things at the lowest level? Absolutely. But let me take a step back and be a little more philosophical with this. If you think about building a switch operating system in a way where the lowest level components are accessible to everyone, vendors and customers alike. The vendors can then do what they've been doing. See, vendors have been all about building that product, that supportability, that turnkey thing. That's great. There are tons of customers, I would say most customers need that kind of thing. But by building it on a platform that's exposed and open in that way, what you're doing is you're not prohibiting the very small percentage of us that want to go lower from doing that. Right? So the vendors then have to think about things in a way that, I want to support maybe my product that sits on top of this open foundation, but I'm not going to do it in a way that prohibits other people from going a different path, for instance. I think that's the real value of this.
You just sort of touched on a point, though. When I go to sell this to the CIO, CEO, the whole C-level people, they're going to say, why do we do this? And so this is the way we want to do networking. and they can say, well, no, we're already staffed this way. And I'm thinking specifically of SD Campus, right? We've been using that term. I kind of like it. In the enterprise specifically, not in the WAN, but that's the paradigm shift, and you have to sell that. I don't know. I think that's kind of a hard sell.
Well, so Phil, if you go to your execs and you say, we want to change how we're doing networking, and it says Dell on the front, are they okay with that, or are they going to tell you it has to say Cisco on the front?
They're not going to say yes. I mean, there's those niche products like where we want to put in F5s or Riverbed, things like that. Where for some reason there's an openness to go in that direction. But generally speaking, no, it's going to be a closed.
I think the big misnomer here is that by moving to an open operating system where you have access to the lower level details, that you have to change the way you do networking. That is absolutely not true. I think that vendors desperately want to maintain that existing turnkey model and are willing to provide that on top of all of the open stuff. So if let's say I'm uber nerd geek and I want to do all of the cool things, I don't have to use their model, but that model will still exist for those that don't want to go that deep. I think it should, actually, because arguably most customers are like that.
I think that's the problem. It's hard to make a compelling argument for, I'll just throw a number out, 90 to 95% of the organizations that somehow this is going to make their life better, right? Because to them, while we all sit around the table understand that there are, operational advantages, if you want to go that deep, most organizations don't. Most organizations want a switch that forwards packets reliably. They don't want it to crash. And really, the feature set to them doesn't change often, right? To them, they don't need the flexibility of being able to add an application to their switch. That doesn't mean that that's not valuable. It is incredibly valuable. But the sales proposition to someone who is right now, typically running a Cisco, a Juniper, or something like that, there's no additional value to say, look at what Dell is doing. Or look at, whoever else is putting out these, these open platforms. It's harder to make that sell. And so, like, when they're going to go up and compete against an iOS or, one of these established platforms, I don't see any additional value. I don't see what the compelling argument is.
Networking is not all that important.
Yeah.
It's something I often mention, right? The data center network itself is something that gets changed once every 10 years and gets ignored for most of the time, except for minor changes. It's not a mission critical issue.
And it's not very big.
No.
So with those of you in this room, considering the criticality of your core network or your data center network, if you want to position it that way, would you look at a Dell? Would you look at a Big Switch Networks and consider them? Or would you be like, too new, too cutting edge, I'm not sure?
I think with proper design, it doesn't matter. I think if you've designed things properly, built things in a modular way.
Oh, you're young and hipster, though.
And seriously, though, I mean, if you can think of a design that limits the scope of risk, right? These things don't have to be rolled out all at once. You can roll them out in very small increments. And so it almost doesn't matter.
I think, for example, testing has to be done. No matter if you use an old style system or one of the new players, it is the same, yeah? And everybody has bugs, yeah? And you will stumble upon them. This will be the same story that we had before, yeah?
Yeah.
I wanted to get your take on this at some point, because you got the benefit of, I think, the most experience around this table.
He actually knows what he's talking about.
Gray hair, is that what you're saying? Gosh, I think all the vendors seem to be moving to Linux. I mean, we heard from Cisco. Well, there was Linux mentioned there, all right?
Yeah.
Theirs is customized, so Dell's isn't. I think there's some advantages potentially on both sides, and you kind of have to pick the poison that you want on this. Having an unmodified Linux kernel gives you the advantage of when patches come out or updates or new functionality comes out, you can just roll it in. And having a Linux kernel there that you can add stuff to may allow us to make this transition to more of a, I'll use the term, software-defined whatever, all right, software control may make that transition easier because we're not trying to go take some functionality and drive it into a proprietary kernel. Now we have a stock kernel we understand, we know how to administer. So from box administration, control system, control plane administration, we know how to administer this thing because we have the tools to do it, Puppet, Chef, et cetera. We can integrate that with the IT organization that understands how to do that. I'm talking, when I say IT, I mean the server side. Then we can integrate the networking side more closely with what's going on the IT or server side.
What about, let me just deviate a little, sorry. Speed of change. you've been around for a long time and you've seen the industry. No disrespect. I mean,
I understand.
I've been around for 25 years, but you've been around for way longer than that, right? And I'm sort of looking back, and there's this sense that networking has been stagnant for 20 years to me. We've still got much the same things, doing much. But in the last 5 years, there's a sense of momentum building up behind change.
Right. Yes.
Would you agree with that?
Yes, absolutely.
Yep.
I
Everything's
first took
changing.
a look at.
It's not just one thing changing; it's everything's changing.
Well, I first took a look at SDN back in 2011, I think it was, and it had been around for a few years. It kind of started around 2008 or so, Stanford, the Clean Slate Project. And when I looked at it, I said, oh, great, this is academia. Okay, it allows them to go experiment with new protocols. This is pretty cool, but it's not going to see the light of day for corporations. And then 3 years later, a customer asked me to go take a look at it, and I took a look, and it's come a long ways in that time. Now, what's kind of frustrated me recently is I'm seeing the adoption slowing down. And I think that's because people are still trying to get their heads around, how do I adopt this? What are the business drivers that compel me to go adopt something this different?
Yeah.
And the complexity involved in it, because now we're talking about, I'll call it DevOps for networking, or network ops, or NetOps. Okay, so a complete paradigm shift in how we manage our networks.
Yeah, I think what you're saying there is this is the drawing in of breath before you go, right, let's get started.
Okay, so what I see is, and the whole thing that got me on this was watching some of the early videos, the recordings that were done by the guys at Stanford and Berkeley, the early researchers, and they said, we need new abstractions for networking. And my software background went, exactly. We're still dealing with complexity that's right in my face.
Yeah.
I can't hide it anywhere.
Yes.
Okay? If I want to go do VPNs, layer 3 VPNs, all this complexity is right in my face. I can't go hide it easily. And I need some way to go do that.
Yep. And that's what SDN is partly. It's one of the many features of it.
That's the goal of some of this change, is to be able to hide that complexity behind abstractions that make sense to us as networking people.
Well, that's almost the core of the SD-WAN story, just to move out from the fabric stories, right?
Right.
Is that
I can hide the complexity of multiple links and different bandwidths and
partial
different error
meshes, full
rates
meshes, multi-topology meshes.
all that stuff just gets hidden, and it looks like this virtual link. It's like, this is cool.
So good segue then. Let's move our architecture discussion on to WAN architectures. We hit security, we hit core. Now let's talk about WAN a bit. We heard from Silver Peak and Citrix, who both mentioned their software-defined WAN solutions in some detail. So one question is SD-WAN versus WAN optimization. Now, a lot of shops would have installed Riverbed. I would say certainly a market leader. And you would just, for WAN optimization, drop a Riverbed box in. Now there's a much bigger market, all kinds of appliances you can choose from. Does what you've been hearing about SD-WAN change your thinking about what your WAN architecture looks like?
Does it have to be versus WAN optimization?
It can be any way you phrase it. I phrase it that way on purpose because it's an artificial argument that isn't really there, John.
Done, you straw man. Yeah, but just because, I think to be the most effective, actually mixing the two things is incredibly beneficial, right?
Yeah.
Having WAN optimization as part of your SD-WAN solution is fantastic.
So qualify that. Does it need to be part of your SD-WAN solution, or you leave your Riverbed box and drop an SD-WAN solution in as well, or?
It's going to be more effective if they're integrated, if they're actually able to make one intelligent decision based on content, destination, links, the whole deal, rather than pre-packaging in some format that then can't be torn apart by a second device to know what to do with it.
Why would you want two devices when one would do?
Well, there is that too. So,
when you
Unless you're in sales.
I'm talking about from my non-consumer side.
If I was a product manager, I know exactly where I would sit. Vendor product manager, I know where I'd sit in that discussion.
When you talk about WAN optimization, like Riverbed or something like that, you're not talking about fully utilizing all of the links that you have, right? You're talking about taking a single WAN link and optimizing across it, right?
Well, Riverbed's going there. Just, I don't mean to single them out as a legacy. They don't do SD-WAN, because they absolutely do, and they're moving ahead with that solution. But
that's what I'm thinking is, I think the WAN optimization is optimizing the way we use every bit of our WAN. And so having something like what we're seeing now, where we can do that with Silver Peak, for example, with what we saw,
the boost upgrade you can add.
Yeah. So it's like
And Citrix as well. They did the stage thing.
Yes.
With the,
Right.
You know,
Yes.
two network cables, cut one, and then it fell over to the 4G.
Yeah.
Can you imagine doing that on a normal router? You know, having 3 links and then falling over from one to the other seamlessly in less than a second, less than half a second.
It's almost implicit in the comments I've heard so far is all of you guys seem to believe in SD-WAN as a thing that's viable, and I'm interested in that.
Of all of the SD variable definition, right? SD-WAN is the one that's going to hit market and actually get adoption the fastest. I mean, it's solving a real problem. Right now, our WAN is difficult. You know, it's the reason why all of us have had very nice careers, right? Is that the WAN ultimately?
I'd just like to point out you'd have a nicer career if it wasn't so hard.
I agree with that. I'm not saying that we can't carve out our own space in the new world, but SD-WAN is going to make, you know, like it really is solving some problems that are existing for everybody, right? So we talk about software-defined data center, and that's a very small group of people that are really, really pushing for something to you know, have this really flexible architecture in the data center. Where SD-WAN, like I come from the VAR space, I can say about 90% of my customers would benefit from any one of the SD-WAN products that are on the market right now. And so I think that you're going to see in the next 3 to 5 years, there's going to be a massive level of adoption of these things, especially because some of the things we've talked about, full utilization of links, the idea of forward error correction, being able to recover from brownout conditions. Right now, our routing protocols don't do well at all. Right, so this idea that we can now detect, because we have visibility on both sides of links. Like I'm a huge believer in SD-WAN.
Farewell to the 1970s in networking.
Exactly.
I mean, we still use OSPF from the 1970s.
Let's get the
We're running up against the cloud. There's an important question here I want to ask in the context of SD-WAN, which is this. The technology that we're seeing is proprietary, and increasingly so as we look at these SD-WAN solutions. Does that bother you or not?
Because it actually addresses a technical need that people want to pay money for, it doesn't bother me that much. So I think maybe it's because I'm jaded by that. But that's the compelling argument. And this is the specific, we've been talking about this past couple of days, this is the specific need I'm trying to address, and this actually does it, as opposed to maybe some of the ambiguity around security, and I want to add orchestration because it makes my life easier, things like that, which is very important. But this is just a technical need where, we need to have uptime, and this gives us that. So does it matter if it's proprietary?
There's another component with lock-in here that I think needs to be part of the discussion. So we might be locking ourselves into a WAN vendor for a while as we buy a product and move. It's going to be hard to get out of it, but what we are getting out of it is that we're removing a lot of lock-in with carrier, which is something that we've had, and we all around this table have fought in some significant way.
Yep.
Like, it's going to come down to internet bandwidth, and it's going to become who can produce it reliably and the cheapest, and you get lots of internet options versus your MPLS or private circuit. So that type of freedom is going to benefit us a lot. So
Commodity bandwidth versus custom bandwidth.
Exactly.
Yeah.
So it might be worth in this scenario trading one lock-in for another simply to break what has been a monopoly in our.
Right.
But I would suggest you can more easy, let's say, change your SDN vendor, chip out new boxes and deploy another one, then you can change your MPLS provider.
Yes. I don't have multi-year contracts with my SD-WAN vendor. I do with my carriers.
Yeah.
Right, and it's so simple to deploy this stuff, regardless of who the vendor is. We've all seen them. You drop it in the branch, and within a couple of minutes.
Any lock-in discussion. You remember when SDN first came out, everybody went, it's going to be anything you do in IT is a lock-in. What storage array you buy, what CLI you're using, but all you need to do is get a business case that says this lock-in is traded off against these benefits, and this reduction in cost or this increase in operational efficiency or whatever it is. Lock-in's not a crime, but we would certainly like to avoid it if we could, and hence the open source movement, which is about being locked into somebody's, and that was a rejection of that. So lock-in's not a problem. I'm happy to accept lock-in in the SD-WAN in the short term, and hope that there's some, and we've had this discussion before, right? As long as standards emerge over time.
And normally we'd resist that lock-in, right? Normally we'd be saying, hey, you should be running LLDP, not CDP.
Yeah.
You should be running LACP, not PAGP and stuff like that. And that's because there is an alternative that we can go to. Short term, though, if you run a virtual chassis on Juniper, is it proprietary? Sure it is, but we accept it because it solves a problem for us.
When 50% of the market has an SD-WAN solution and they're all incompatible, the vendors will be forced to converge.
Exactly.
In the
So
meantime,
one may
I'm going to
come.
save millions of dollars a year,
Right.
multi-millions for most companies in WAN costs. perfectly acceptable trade.
Exactly. So while normally I'd probably say, run away from that, I think it solves, as a concept, it solves the problem so effectively. The benefits outweigh the lock-in in the short to medium term.
Anyway, the lock-in's a little bit diminished because everybody's using SSL VPNs and IPsec VPNs anyway. So it's not like they're desperately, utterly incompatible. They are all built on the same foundational technology.
Except the thing that actually makes it clever is the proprietary bit.
Yeah, that's right.
The data analysis, the mechanisms and protocols by which those things are communicated, the ability of the devices to actually do something with that information on the remote ends. So I think you're right, a lot of the underlying protocols are the same things, are standard protocols that we're just repurposing, with the exception of Cisco that's taken a whole bunch of their proprietary existing protocols and repackaged with a controller. However, there's still that element of the smart stuff is the proprietary. Whether it ends up being standardized down the road will be very interesting to see.
I could see like a dumb mode. Like there's a default mode for SD-WAN vendors to interoperate, a bit like other technologies we've got where there's vendor has a plus mode.
Like Trill versus Fabric
multi-link PPP sort of.
Yeah, multi-link PPP or EI OSPF, and then in the early days of OSPF, everybody did Area 0, and then became areas, and then became not so stubby, and then totally not so stubby, and stupidly stubby.
I think part of the lock-in discussion as well, right, is the reason why we avoid it is because of the pain it causes to get out of it, right?
Yep.
So lock-in is never 100%. We can always make the decision to walk away from whatever it is that we're locked into.
Yep.
The problem is that it's the amount of pain that's required. But think about what SD-WAN is and the level of lock-in. How hard is it to stand up a second infrastructure? It's really not that hard. All you have to worry is about how are we going to transit between the two. It might be a hub site, it might be hub and spoke between two SD-WAN architectures, but we're not talking like it's going to be like a 3-year architectural change if you wanted to switch SD-WAN vendors. I would imagine it would be like a 3-month architectural change for most companies to be able to go from one vendor to another if for whatever reason vendor A isn't
The use
providing.
of software for rapid rollout is...
Right. So, but because of that, I mean, the vendors are going to have to remain competitive. We're irritated at carriers because there's absolutely no competition in and amongst them. Because SD-WAN vendors will have to be competitive to keep your business, the chance of you needing to leave it because of lock-in is a lot less likely.
Well, guys, that's a good place for us to close. We are up against the clock, so what we're going to do is we're going to go around the table, starting with Terry. And if you would, just state your name, and if people can follow you on the internet, a blog or a Twitter handle, that kind of thing, let them know, and let's go rapid fire.
Terry Slattery, and I blog at netcraftsman.com and nojitter.com and TechTarget.
Michael McNamara, I blog at blog.michaelfmcnamara.com at mfmcnamara.
Matt Oswalt, Mearden, on Twitter, Mierdin, and also at keepingaclasslist.net.
And I'm Greg Farrow. You can find me on my blog at etherealmind.com, and on the Twitter is at etherealmind.
I'm Brandon Carroll. You can find me at Brandon Carroll on Twitter and at globalconfig.net.
Jordan Martin, you can find me at the very original jordanmartin.net, as well as at BCJordo on Twitter.
Philip Gervasi, you can find me at network_Phil on Twitter, and then just plainoldnetworkphil.com is my blog.
John Herbert at Mr. Tugs on Twitter, and movingpackets.net if you want to read my drivel.
John Langmark, you can find me on Twitter at Blinken_Lichten, and I blog at dasblinkenlichten.com.
Ethan Banks, ethancbanks.com, and packetpushers.net, and at ECBanks on Twitter.
Dominic Picard, you can find my blog at networkautobahn.com, and my Twitter handle is also networkautobahn.
And I'm Stephen Foskett. I'm at sfoskett on Twitter. You can find me at blog.fosketts.net and at techfieldday.com.
Well, everyone, thank you for listening to the Packet Pushers podcast today. You can find this and many more fine free technical podcasts along with our community blog at packetpushers.net. And you can follow the show on Twitter at Packet Pushers. You can also find us on LinkedIn. You can like us on Facebook, and if you would, please rate us on iTunes. And you can email Greg and I. We monitor packetpushers@gmail.com. Last but not least, remember that
Too much networking would never be enough.
So thank you guys for watching. It's been great to have so many people watching us all week long. Again, if you'd like to catch more videos like this one and like the rest that you've been seeing for the last 3 days, just go to youtube.com/techfieldday, subscribe to the Tech Field Day YouTube channel, and you'll get alerted whenever we upload new videos. And check out the Tech Field Day website as well, techfieldday.com. But for now, thank you very much for joining us, and we'll be back in a couple of weeks from Austin, Texas for Tech Field Day 10. Bye-bye.
Bye-bye.
Bye.